Hello, welcome back. This is the third episode of Class 9 Physics series. We have learned about distance, displacement, velocity, acceleration, and basics about graphs. If you have not or want to revise, you can check the first two episodes somewhere around here. I wanted to go in detail as per the book, but as the government is looking for an alternate, concise syllabus, I too am approaching it differently. I will be choosing topics essential for your higher studies. I wanted to discuss the most famous laws of motion by Isaac Newton, but I felt there is a need to understand gravity first, which I am not sure why the curriculum left it out. This will not only help you understand the laws of motion better, it's also my favorite physics topic, so let's learn gravity. I am Yogesh and this is the Amateur Bhutanese. Gravity was discovered by Sir Isaac Newton. So first let's learn a little something about one of the most important scientists the world has ever seen. Sir Isaac Newton was born on Christmas Day 1642. He was an English mathematician, physicist, astronomer, and many other things. Newton formulated the laws of motion and gravity. He calculated the orbits of planets around the sun and even told the exact shape of the Earth as an oblate spheroid. He has many accomplishments to his name, out of which laws of motion and laws of gravity shaped physics. His story of the discovery of gravity is very famous. It says he discovered gravity when an apple fell on his head. This is partly true, but not the apple hitting his head. He saw the apple fall in the garden and thought, why does anything fall to the ground? Why not fly up? With this very simple question, he discovered gravity. That is why I keep saying, always ask questions. So let's start with a very simple question. What is gravity? Gravity is a force of attraction between all matters. You can say gravity, according to Newton, is like force of attraction between two magnets. Like this. With magnets, I will now try to explain the laws of gravity. If you see these magnets, it shows the very basic concept of gravity. Gravity means force of attraction between two objects. From these magnets, we can learn many other things. A larger body will attract a smaller body, or a bigger body or object has higher gravitational force. Gravity doesn't mean pulling down, it means pulling towards each other. Gravity is higher when the objects are closer. So that means your velocity increases as you near the object. And you know what happens when velocity changes? Change in velocity with time is acceleration, which means gravity is a force of acceleration. Using these magnets and point number 2, I'll show you a very interesting thing about our home planet, the Earth. Consider this big magnet, the Earth, and this portion is the North Pole, and this is the South Pole, and this is Mr. Doji. The white paper is Mr. Doji's head. So when it comes to the North Pole, Mr. Doji will be staying like this. Now, what happens when Mr. Doji comes towards the South Pole? Very simple. The gravity will act like this. The head will come down. Yes, a person living in the North Pole and the South Pole will be facing the other way. Because for the North Pole, the down is this way. But for the South Pole, the down is that way. So never say gravity as the force which pulls us down. Gravity is not a force which pulls us down. Now that gravity is very clear to you, let us learn why it is important in our future. We will be learning a very simple thing today, the difference between mass and weight. But before that, we need to learn what is inertia. Inertia is the resistance of a body to a force. Any object resists change to its rest or its motion. This is known as inertia. The measure of inertia of a body is known as mass. Consider this paper. If I crush it, it can be crushed very easily. There is change in its structure. But what about this magnet? There is no change of structure even when I put force. That means it has high resistance, which means high inertia and higher mass. Mass is the measure of matter in a body, and it is measured in kgs. If it is measured in kgs, then what is weight? Well, that's where gravity comes into place. Weight is the result of gravity on a mass. Weight is equal to mass into gravity. In Earth, the force of gravitation has a value of g equals to 9.8 meter per second square, which means when an object falls from the sky to the Earth, it falls at an acceleration of 9.8 meter per second square. So, using the formula of weight equals to mass into gravity, we know weight equals to kg into meter per second square. This is denoted as Newton. The unit of weight is newtons, denoted by capital letter N. You may have seen facts on Facebook or any other page saying you weigh less in other planets or more in other planets. This is true because the gravity changes with size of the planet, if you remember the third point. For example, as the moon is smaller, it has a lower gravity, and hence you will weigh less there, but your mass will remain the same. Mass does not change wherever you go in the universe. There are lots of interesting things to talk about gravity, but we have to get on with the curriculum. However, I assure you, this is not the end of gravity. It will resurface again and again. With the basics of gravity now clear, we will continue with Newton's laws of motion in the next video. If you have any queries, never hesitate to ask me. You can follow me on Instagram at the Keyboard Warrior or on Facebook. Any clarifications you need will be provided with. Till then, keep safe, be happy, and never stop asking questions. Today's episode is also a tribute to a brilliant mind fascinated by physics. He talked about physics with a fascination that I too share. Sushant Singh, an actor but more a learner, among the stars he rests now. Bye-bye.